So with that in mind, let us go to the first conjugation property. Okay, first one, if x of t is real. Okay, if x of t is real, so what will happen? X of t is real. This implies what? X star of t should be equal to x of t. Correct? If x of t is real, x star of t should be equal to x of t. So what will happen in frequency domain? Just now we have seen that x star of t will have x star of minus j omega as the Fourier transform, and that should be equal to Fourier transform of x of t, which is x of j omega. So clearly you can see that this is looking like x star of minus t is same as x of t, which is conjugate symmetry property. So if the signal is real, then Fourier transform satisfies which property? Conjugate symmetry property. Okay, so now let us write down this in terms of real and imaginary parts. Okay, yes, so what is x of j omega? X of j omega is nothing but xr of j omega plus j times xi of j omega. So from this, what will happen? X star of j omega should be equal to xr of j omega conjugation, right? So minus j times xi of j omega. Okay, and from that we see that x star of minus j omega means wherever there is omega, replace with minus omega. You get xr of minus j omega minus j times xi of minus j omega. So in that way, we have x of j omega and we have x star of j omega. But if signal is real, what is happening? X star of minus j omega and x of j omega are same. So this implies xr of minus j omega, correct? X star of minus j omega is this. So we'll get minus j times xi of minus j omega is equal to x of j omega is what? It is xr of j omega. I'll put a line here. Okay, straight line. Yes. Okay, xr of j omega plus j times xi of j omega. So this implies equating and real and imaginary parts. What you get? You get xr of minus j omega equal to xr of j omega. This implies what? Real part is even. Okay, so this real part is even. Similarly, what do you get? You get xi of minus j omega to be equal to minus xi of j omega, correct? Yes. So minus xi of minus j omega equal to xi of j omega, which is same as this. So this implies imaginary part is odd. Okay. So what is that you have seen? If the signal is real, Fourier transform is conjugate symmetric, and from that we got what? Real part of the Fourier transform is even and imaginary part of the Fourier transform is odd. Okay, and also we will talk about polar form. So just now we have seen that x of j omega equal to how much here? Modulus of x of j omega into e power j times angle of x of j omega. So this is the polar form. So from this, what will happen if I take conjugation? X star of j omega would be equal to how much? This is real number. So conjugation has no effect. You will get modulus of x of j omega into e power minus j angle of x of j omega. Why? Because you take conjugation, e power j theta will become e power minus j theta. Okay. And finally, let us see what is x star of minus j omega. So this is equal to, yes, wherever there is omega, replace with minus omega. You will get x of minus j omega would be equal to multiplied with e power minus j angle of x of minus j omega. Okay, yeah, so in that way we got x of j omega and we got x star of minus j omega. But if x of t is real, these two fellows are equal, and hence, okay, as x of t is real, as x of t is real, what do we have? We have x star of minus j omega is equal to x of j omega, correct? So let us substitute these two fellows. So what do you get? You get modulus of x of minus j omega multiplied with e power minus j angle of x of minus j omega is equal to, what is x of j omega? That is modulus of x of j omega multiplied with e power j angle of x of j omega. Now equating these two, what do you get? This implies modulus of x of minus j omega is equal to modulus of x of j omega. This implies what? Magnitude of CTFT is even, correct? Modulus of x of minus j omega equal to modulus of x of j omega means what? Magnitude of the Fourier transform is even. And what happens to the angle? What did we get? Angle of x of minus j omega is equal to minus angle of x of j omega. This implies what? Phase, right? So phase of CTFT is odd. Okay, so in that way, what is that we have got? If you talk about real and imaginary parts, what will happen if the signal is real? What will happen to the Fourier transform? Fourier transform is conjugate symmetric, and correct, the Fourier transform is conjugate symmetric, and from that we got what? We got real part to be even and imaginary part to be odd. And if you look at that in polar form, what did we get? Magnitude of the Fourier transform is even and angle of the Fourier transform is odd.